Hello and welcome. I'm going to record my attempt at the Road to Las Vegas battle number 9. I was kind of hoping that I would have geared up enough to do this one or attempt this one in Python, but don't think I'm ready for that. So I'm just going to do it regular Excel and maybe try it in Python later. So let's start my timer, hit start, download the file, and here we go. So copy, put it over here. Let's open it up. I've prepped a little thing here just in case I might need it. I'm not sure if I will. Okay, so get rid of that. Just want to clean up this data a little bit. 100, okay, that's not too bad. We'll make it a table. I'm going to name it T for ease of reference. And then department aisle, let's make that type, prod, price, inventory, fine. Okay, so how much inventory? So it goes countifs. Countifs. T inventory where T type is this. Oh, sorry, where T in, sorry, sumifs, not countifs. Okay, and just, I shouldn't have arrayed it because I want to test it on the example. So do that and that checks out. So 45, 12, 19. Oops. 45, 12, 19. And checksum is 163. Okay, total retail value of the inventory, price times inventory. So call it retail, this times this. Okay, so then it'll be the same thing, but we're summing retail instead of inventory. Oh, sorry, and we're summing product instead of type. And that checks out. Okay, good. So 2930, 6698. Sorry, 2930. Yes, 0 at the end. 6698. I was worried for a minute there. And 4752. Okay, and then the checksum 82994. Typing it in because I'm worried about commas if I copy it. Anyway, okay, level 3. Level 3, the teams will race inside the store. The store has aisles, and the teams need to run through these aisles to complete the race. Each cell measures 1 meter by 1 meter. To figure out the shortest time required for each race, consider the aisles the team must run through and their speed. The race always starts in cell A1 and ends at cell AG15. Do not count the starting cell. Fine. So my key question here is it always an odd number of aisles? The len of this plus 1. Actually, no, let's just say text split this by comma. We'll put a minus minus in front of it. And then I want columns of that. Yeah. Okay, so the answer is it is always an odd number, so that's good. So then, to get down one aisle, you gotta go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So it's 14 per aisle. And then it's, to get to C is 2, so to get to the end is column of this, minus 1, which is 32. So it's 32 plus 14 times the number of aisles. So I think the answer is going to be, oh, wait, what? Hang on. Huh? Round times the nearest second. Why would I have to round? Oh, speed in meters per second. Okay, sorry. So this is aisles. This is meters, which should be, what did I say, 32? Yes, 32 plus 14 times that. And then seconds is that divided by meters per second. And what do I do with rounding? Round up to the nearest second. Okay, so, and that does match 15. Good. Round up this, comma 0. Okay. So 19, 15, 44, 19, 15, 44, and the checksum is 422. Okay. All right, level 4. Start shopping. Figure out the highest possible value of the shopping trip based on the aisle and time limit. Okay, interesting. It needs to start in cell A1 and end in AG15. Take 1 second to put an item in the cart. Oh man, this is tough. 5 units of any individual product. Keep in mind the case where they, oh, whew. Okay. Do you have to go down all the aisles? I think that, oh, sorry, there is only one aisle. Okay, fine. Fine. So then, oh shoot, I just need to move all these over so it'll work with this. So I got that. My aisles is just a fixed number, but that's fine. I can carry over the same formula. Meters is always going to be 46. That makes sense. So then my seconds is, I guess I don't round for this. I guess I do, yeah. 1 second to put item in a cart. Okay. In mind, that may be the case where the store is less than 5 items available for a specific product. Fine. Okay. So what are we doing here? This is time moving. So then time taking is just going to be time limit minus that. And then I need to figure out what all is in these aisles. Let's just see what is the next level. 3 teams competing, all teams given a chance to shop, fine. They will all have the same amount of time. They move at different speeds, fine. Choose different aisles, fine. The sequence of shopping is as follows. Red goes first, then green. Oh, wow, this is going to be really hard. The team is limited to no more than 5 items of the same product name, units. Okay, one of the highest priced items is the mixed bouquet in aisle 3. Only 13 of these. Example 5, the red team will take 5 of these, green team will take 5, and the blue. Okay, fine. Calculate the maximum possible retail value for the given team, assuming all teams aim to maximize their total scores. Oh, but sorry, there are designated aisles. Okay, fine. Then it's fine, I think. Whew, okay. All right, so I just need to figure out what is available. And that's going to be just filter to the aisle for this. So we'll say filter. Just start with T, where T aisle. There's a space. Okay, fine. Where T aisle is equal to this. And that gives me this. Just take my headers here. So I don't care about the department or type. I care about product, price, and inventory. So whatever, let's say it doesn't matter. I'll just leave them all there. So I guess I want to sort this on column 1, 2, 3, 4, 5, descending. So here we go. Just take as many each thing as we can. So we've got a total of 30 seconds. Fine. So 30 equals this minus, sorry. Yeah. So time left. This is what they take. So it's going to be the min of the time left and the inventory and 5. Then it's this minus this. And that's it, right? Yes. So then value is just going to be some product of this with price. 45,948, please. Yes, good. Okay. So then I just need to make everything here link to there. Okay, so example 4. So we're going to say x lookup this in here, returning from here. And then we're just going to have this point to that. We're going to have this point to that. It already does. This point to that. It's fine. This point to that. And this point to that. And then I think we're good. So let's see. This only points to, oh, no, has to point to that. That's the only reference there. That's fine. This is fine. This is, oh, no, time left is not a fixed number. It is linked to there. So then this is the answer. And these are the answers that I need. And the input cell is over here. Okay. So 25578, please. 25578. Yeah. Okay, good. 25172. 25172. Sorry. 22679. 22679. Beautiful. Okay, and the checksum is 407865. 407865. Okay, level 5. This is going to be trickier, but not actually enormously trickier, I think. So what do I need to do? I think what I need to do is start with just a copy of T. I want all, please, because I want the headers. Just good to have it here. So then red goes first, then green, then blue. So red, green, blue. Okay, so first thing I need to do is some calculating. First thing I need to, example 5. Then I need to XLOOKUP that in here, returning from here. Now I'll just take all these headers so I know what is what. Put it up here. Oops, sorry. Put it here. Okay. Team 4. What? Oh no, sorry. Team blue. There we go. Yes, fine. So what's the question? Oh, some to calculate the maximum possible retail value for a given team. Fine. Okay. So fine. So then I need to know. I don't need to know which aisles right now. Yeah, let's just do it. I need to text split this by a comma. Sorry, by a comma there, so it goes into the column. Put minus minus in front of it. Okay, then I need rows of that. Do they always hit the same? No, they don't always hit the same number. That's good to know. So then time for each team is going to be, what did I say, 32 plus 14 times this. Fine, in this case they're all the same, but that's okay. Sorry, that's meters. So seconds is going to be round up this over this to 0 decimal places. Then shopping time is going to be the time limit. I need to lock that minus these. Okay, so then, oh, and sorry, this I need to link. No, do they always go in the same order? Red team always goes first, followed by green. Fine, good. So actually, sorry, I want to sort this. So actually, I probably don't want the all then. So just go T, sort T by 5 minus 1. Okay. So then, so what did I do before? I said how many they take, how much time is left. Okay, so I'll do take for each of them, time left for each of them, and then I also need prod left for each of them. Prod left, okay. Oh, and then I need a flag, I guess, for who can has aisle, and that's going to be x is number x match aisle against this hash blocking the row but not the column, and we'll make that minus minus, please. So let's just format so I can see this. 0 minus 0 0. Okay. So red has aisle 3 and aisle 3 and blah blah blah. Green should also have aisle 3. Sorry, I need to lock this. Okay. So now we're good. Okay, so then time left starts with this. Okay, so then what they take is just the minimum of their time left, the amount, and 5. Fine. So for red, that's going to be min of time left, inventory, and 5. And for green, it's going to be the min of time left, 5, and what's left after red. And same for blue. And then this is going to be inventory minus what red takes. And then this is going to be this minus what green takes. And this minus what blue takes. Fine. But then this has to be if this. Then it's all that stuff. Otherwise it's 0. And then it's just here, that minus that. Yeah, okay. So then the mixed bouquet, yes, so they take 5, they take 5. Oh, why do they only take 1? That's not good. Oh, what? Something is not locked in, that's fine. All right, so you're taking what? No, that's totally wrong. If green, yes, the minimum of that, sorry, okay, I screwed up this formula. So you're interested in the minimum of time left, inventory, and 5, if that, yes. You're interested in if that, yes. The minimum of time left, yes, but inventory should be after red. So that, and same for blue, yes. Okay, so now, come on, they take 5, they take 5, they take 3. Okay, good. Yikes, this one is tougher. Okay. Calculate the maximum possible retail value for the given team, assuming all teams aim to max. Okay, fine. So, so then my retail value is going to be, sorry, I'll put it over here, is going to be the sum product of what they take with the, with the price. So then, first answer I want here is just what is red's value, because that's the one I think in the bonus question, and then the second answer I want is XLOOKUP this team in here, any of them, returning from here. So this is given, this is red. I guess I also need winner. No, I don't. I can just say if those two are equal. Okay. Oh, hang on. Yeah, 4, 3, 2, and 4. Yes! Haha! Hooray! It actually worked. Amazing. I guess I wasn't really expecting that. Okay, column input cell is here. So that all calculates. So the given team gets this. So 106, 603. Yes, it's looking good. Okay, 15, 830. Yes. 36, 321. Okay, and then 1601443. 1601443. Okay, bonus time. Hello, I'm back to do a rare second take of a piece of this because everything up to where you've watched so far went quite smoothly, and then I completely choked and got every single one of the 3 bonus questions wrong, with, basically decent workings, but just misinterpretations, wrong ideas, all kinds of silly mistakes. So rather than making you watch me do them all wrong, I'm going to quickly show you what I did wrong and how I could have done it right. So first one, calculate the total retail value, price times inventory for the 11 aisles, and then I just stopped reading. And the question goes on to say, what is the retail value for an aisle that has the highest one? So I just took sum of T ret. We can do this pretty neatly because you can say sum ifs T ret, the retail value, where T aisle, there are a bunch of weird spaces, so those names are, anyway, it doesn't matter, where the aisle is sequence 11, and that will give you, again, you can, if you're familiar with dynamic arrays, you cannot put a calculated array for the criteria range or the sum range, but you can put a dynamic array for the criteria. So this will spill out and give you 11 different values, and we're just interested in the largest of those, so we can just wrap that in max, and that's the actual, well, I think it is the actual correct answer. Bonus 2 is an interesting one because I learned something new from this one, so let's go and look at what I did here. So first, I just added a column to say, is there a weight in here? And the way I did that was I just said text split on ounces or on ounce or pound, and count the columns. And if I filter, you'll see that is matching on everything that has ounce, everything that has pound. It's also matching here on dozen, so I have to watch out for that. But I got to here, I looked, I said, okay, it looks like, and I scanned down to check, all the ounces are OZ period, OZ full stop to my friends on the other side of the Atlantic. So I just changed that to that and copy down. And now I've got just things that are pounds and ounces, and I can quickly kind of visually check, yes, okay. and actually I did an additional check, which isn't here anymore, but I'll just put it in. So I did text after, because I could see scanning down here that the weight was always at the end. So I did text after of this by a space and give me the last match. And I could visually scan down here and say, okay, yeah, I've got 1 pound and all the rest are ounce. So then I could do, well, I'll just show you how I built up to it, how I actually did it. Change that to a -2, and now you've got the last two pieces, which is the number and the ounce. And then I took text before the space on that to get just the number. So that gives me all the numbers, and then I just manually tagged, those times 1, and then I just changed the 1 row with a pound to 16. So that all seemed to be working. That sums up to 218.5, rounds to 219. And then I watched the video and heard one of the commentators say, yeah, you got to be careful with these because sometimes the ounce is at the start instead of at the end. And I thought, wow, I was totally dumb. I only looked for it at the end. And then I went back and watched the recording and I realized actually it wasn't that I only looked for it at the end. It was that I tried to identify it this way. And what I eventually figured out was that the problem here is that text split is case sensitive, which I never knew. And that's, well, that turns out to be a big problem because all the cases where ounce appears early in the description, it appears with a capital O. So like here, 5.3 ounce, 8 ounce, 16 ounce, and so on. And so I just missed all of those. And there, similarly, when pound appears at the start of the description, it appears with a capital letter, just by coincidence. But it meant that I missed all of those. So oops. So what could you do instead? Well, the easiest thing probably is just to make this. Oops, sorry, not lower there, but lower over here. When you're doing the identification, and then you'll at least see this is everything that has, sorry, now I've still got the period in there, so I need to drop the period. Do that. So then you've got everything that has ounce or pound. You still have the issue with the dozen that you need to clear out. The other option, which is what I came up with after, and actually is probably a neater solution overall, is first just to have a list of acceptable weights. That's OZ, OZ period, LB, and LB period. And then the idea would be we'll basically text split this on space, see if any of these match that, and if they do, take the one before. So what does that mean? It means let SP be text split of this by space. Then let, so I want to X match my 4 acceptable weights lock against SP. And that is going to give me either 3 or 4 errors and possibly 1 match. So I want to get out the 1 non-error from that. So I'll just wrap that in if error 0 and then sum them up. I'm assuming here that there won't be more than 1 match, which I think is the case. I mean, I should say this is a solution that's kind of optimized to work on the actual data that's here. To solve the general case of this problem for all plausible text descriptions is a way harder problem that I'm not even contemplating. Anyway, so that tells me where I get the match, and then I just want to index on SP of all of that stuff -1, and that should give me the number if there is one, and value otherwise. So then if I filter to just these 2s, you can see it's erroring out for a dozen, which is fine. That's what it should do. And yeah, let me just put the filter on here as well. And then we just need to multiply the pound ones. So what we can do for that is index multiplied by if is number. And now that I know to be aware of case sensitivity, I'm going to search for LB in here. So if that's a number, then 16, otherwise 1. And then I can wrap the whole thing in an if error. The whole thing, I guess just meaning this end bit, if error, all of that, then 0, and then sum that up. And that gives me my answer. I should say here, this search for LB is not allowing for the possibility that LB will appear intra-word, so it's worth just doing, again, I said this formula is just optimized for what's actually here, but if you filter for contains LB, you'll see there's no words that have it in the middle. There's only a handful of pounds at all. So anyway, that's how to get the actual, the actual answer for that one. And again, that has to be rounded to 0 decimal places. And then bonus 3. So this was just stupid. I actually said at some point in the video, as I was making this table, oh, do I need to add the winner? I didn't. I just calculated 2 columns, read and given. I didn't have these in at the time. And then I just wrote a formula, because in my head I was thinking the given team was the winning team, but the given team and the winning team are 2 different things. So I just said red is equal to, give me the red value if red is equal to given, and sum that up. So I got the sum of the values where red is the given team, not where red is the winning team. Totally dumb. So then here I just added another column called, I also kind of briefly mentioned, oh, I hope there aren't any draws, that would screw me up. So when I did it afterwards, I added one column here to say, give me, if red is equal to the maximum value, then give me red, otherwise 0. And I added a second column here to count how many times the maximum occurs. And so you can quickly scan here that there's only ones, so there are no draws, and then you can sum up this column to get the actual correct answer to bonus 3. And if I had realized that everyone was going to find this case kind of hard, and that the scores would come out as they did, I would obviously have taken a little bit more time to work through all this stuff. But in my head, the specter of Andrew Nye speeding through this and being done minutes before me was hovering over me, and so I raced through the bonus questions and got every single one of them wrong. But anyway, it still worked out, because I guess level 5 was, well, I knew level 5 was pretty tough. So hooray. That's all I got for today. I'll see you next time.